Good evening, good morning, everybody. Um, it's unfortunate that I can't be with you live, but I'm afraid that time zones impose a certain impossible structure upon the world. Um, anyway, so Miriam asked me to come on and have a chat a little bit about my project. So I put some slides together. Um, And if anybody is interested to hear more, yeah, please get in touch. I'd love to chat about the details. Um, so the project I'm working on is modest little one. I want to turn language models completely upside down, make them small and dynamic, where currently they're wonderful, but they are large and extremely expensive, which I've tried to summarize in this image. Had some fun playing with AI and Grok image creation, trying to contrast what I see as the current state of language models and what they should be. That I mean, it's just so clearly upside. I mean, they're wonderful, but it's sort of upside down to what they should be. They're People are talking about doubling the energy production capacity of countries and building new power stations to feed the hungry things. But our brains, our cognition works on the power 20 watts, about 20 watts, the power of a light, of a small light bulb. Um, and So it should be possible to make it work in the ultimate edge compute. I mean, brains are the ultimate edge computation. So I've tried to summarize that by having like edge compute being they should work on a cell phone and they should work on the power of a light bulb. And the light bulb also kind of symbolizes another aspect of the whole thing, which is that the current LLMs, wonderful as they are and as responsive as they are, they're not creative. So they're power hungry. They require enormous training periods where humans are kind of adaptive. The creativity of humans defines our intelligence, but current language models require enormous training periods at great expense and great power consumption. And they try and do everything at once, and so they bake in one perspective, trying to grab everything completely, biases and ideas once only a time of training, whereas our intelligence is defined by its creativity and ability to see different, even contradictory perspectives. We need true edge computing just as the brain is edge computing. Um, so this is another illustration of what I'm talking about. I think that so this is a picture of one of Stephen Wolfram's computational automata, where he has a simple rule which generates structure, which is um, a creative, which is constantly new. Um, And I think the same thing is happening with language models, but language models are trying to learn all of the structure at one time. So I see it as kind of like it's a tail chasing impossibility because these computational automata, they constantly create new structure. So I think what's happening with cognition is actually we're constantly creating new structure. Language models capture a lot of it, but they've got it back to front. They're trying to take the thick end of that pyramid first. It should be working from the thin end and creating structure as we go. So I see it upside down in the sense of being this sort of upside down pyramid where we should be working from uh, the small end and creating the immense structure of meaning in the world, and not trying to capture a complete structure of all meaning in the world one time only, one shape, one form, biased to one point of view. Whereas our individual's perception of the world creates worlds of novelty which never end. But and this is a good thing because we don't want creativity to end. I mean that would be a tragedy for art, for meaning. So it makes sense that there is no end to the creation. And so let me just pop that up there. Why would this be the case? Why would it be that the structure of cognition and language models it constantly gets bigger and doesn't end? How could that happen? Well, the thing, I mean, actually, I've been working on language models for a long time, so I have a broader perspective. And I was working on abstracting grammar, and what I found was that abstractions of grammar actually generate contradictions. This has been missed by the current technology, which has come from more of a place of technology, where you have this technology for finding patterns, and they applied the technology of finding patterns to language. And once they got big enough, they started getting wonderful results. But it's coming from a place of technology which assumes that what you're trying to do is find patterns. What I found was that when I looked at trying to generate the structure of grammars, you got contradictions, and so I followed this thread of insight, and I found that it was reflected in all kinds of other fields in philosophy, mathematics, and trace it down to this. The idea is that meaning actually generates contradictions, and so and it has a long history in philosophy that people have noticed this. Such as the famous liar paradox, that simply the statement itself, this statement is false, is a contradiction in itself. Because if it's true, it's false, and if it's false, it's not. It's true. So it's both things at once. And I think that actually all of cognition works like this, and language models, language. I mean, this is a statement in language. So it's just a demonstration that within language, language has contradictions within itself. And so one thing can be many, and meaning can grow. And I think this is what happens. It's evident in the meaning of the liar paradox, and that manifests in the very structure of grammar. In language models, but at the moment it's being ignored. So at the moment it expresses itself as largeness. They get very large, but never large enough, and never grasping everything, and no apparent structure, because the structure seems to be a bit tangled and mixed up and not obvious. So I think it's captured in the largeness, but we're not seeing it for what it really is, which is this dynamic ability to see many things in the world. But so it's reflected also so it's been the theme in philosophy for 200 more years, and most strongly at the moment in postmodernism, the idea of subjective truth. And this is actually, I mean, it's actually destroying society, that we have these conflicts about that there is no truth, or so philosophy has come to a point where there's a lack of any kind of a lack of faith in a nature of truth, or that postmodernism anchors this lack of this truth, this contradiction, which is become also evident in philosophy, in the ideas of identity and power. But I mean, I think that this can be actually the greatest deliverable of AI research, is actually to provide a better basis our understanding of truth. It doesn't need to be only in terms of identity and power. We can have a basis for consensus if we can see how contradictory truths actually emerge naturally as different orderings. So truth can contradict, but not just anything can be true. We can see and agree in the process of ordering in different ways how it differs and what differences are possible. So it's a potential for a new anchoring of social consensus in a kind of objectivity. So I mean this is a big goal, but it shouldn't surprise us because with AI we're looking at cognition. This is the very nature of our thought. So it shouldn't surprise us if AI has consequences in philosophy and the way we conceive society. Um, so big goals. Um, on the concrete, technical, what does it mean for LLMs? It means the structure of LLMs is right. It's meaningful, but it can't be learned. You must generate it. If you can get contradictions and you want to have you want to be able to find which structure is most appropriate for the situation, for a particular situation. You want to be able to see novelty. Um, but that's fine because while the current technology for language models is based in this idea of learning, which comes from the tradition of technology, actually the language, which has pushed it in the direction of becoming larger, but for language, this large structure that we're trying to learn, we know what it is. It's actually the symmetries. For other problems, maybe you need to learn each separate piece of structure. But for language, actually, it's very simple. It's the symmetries. So we just need to change the idea about technology from learning or trying to learn everything to finding symmetries. So this okay in the concrete for technology. This is an example of the way I see language models working at the moment. So language models they try and find group words which make similar predictions, and then they use those similar predictions to generalize sequences. And so the way that they learn those groupings, these predictive groupings, is that they observe shared predictions in a database over an enormous training period, and they adjust weights between words on that basis. So in this little animation, you can see the sequences: people pay a call and people make a call, and so pay and make are given weights which reflect their joint prediction of a call. So that's what language models, that's like a very simplified version of the way that language models learn the structure that they learn. They learn to predict things, and the way they do that is by adjusting weights. So I'm saying that the same information is just a symmetry. It's just a symmetry in the network. And you should be able to find those symmetries. You don't need to find those symmetries in a rigid fashion in a single large training period. It should be possible to find those symmetries by other means, just by looking at the network. And one way that you might find symmetries is by setting a network oscillating and seeing, because oscillations will be constrained by joint predictions as well. So that was the initial hypothesis of the proposal of this project. But the problem, I mean, so I've had looking at different problems. One is how you for a sequence network, how are you going to have the post context of a call informing the grouping of pay and make. You sort of have to go backwards in a network. Um, so getting a little bit more into the weeds of what I've been doing. Been running now officially for 8 months, about 12 months since actually I put the proposal in. Currently at milestone 4 of 7, and I have some solutions to some thorning problems, in particular that going backwards problem. I think I now have a solution for. Um, and here is so this is what I'm working on at the moment. Remember, I'm trying to find these predictive patterns, which at the moment in language models we learn one time only by adjusting weights. Trying to find it dynamically as a predictive symmetry. Um, so here's this pay a call, make a call example again, and here's a way that I've decided it may be possible for the network to be feeding that context information backwards. And it would, so you have say you provide a prompt to the network, you input the sequence pay a call. And the function of the language model would be to generalize that to make predictions about other sequences, like pay and effort. And I'm using this example in particular because this actually dates from the 1990s. Some work I was reading by a man named Peter Howarth, and he found that students of English tended to make errors. Early students tended to make errors along the lines of shared contexts. So to say pay and effort in English is actually a little bit disfluent. But students tended to make those kinds of errors. And Howarth proposed that they were making those errors on the basis of shared context. And this really got my attention because I was also looking at structure based on shared context. But why would they be making these kinds of errors at an early stage of learning the language? Well, it's relevant to my problem of how the information travels back from the context. And the way I've struck on that this might happen is by disinhibition within a spiking neural network within the brain, really. So the prompt is pay a call, and then a call can have connectivity which disinhibits other words which precede it. So you provide the prompt, pay a call, and then that can disinhibit other words which precede a call in in a corpus, in a body of language, observed language. And then you might have background energy, because a word is not actively inhibited, then you find that just the background energy activates that word, and as that word is activated, it might then activate other sequences. So in this way, you get the sort of forward and backward activation, which might be what is implementing these kinds of context generalizations in our own networks, and that might be a way to implement that in practice. And then there are ways of and that could generalize more broadly. So you'd have because now you want to have a way where I mean, because pay and effort is actually disfluent. So what could be blocking that mechanism? Well, it might be a broader summing of contexts where pay attention is another possible continuation of pay attention is perfectly fluent combination in English. Um, but attention, but you don't see examples of sequences like make attention, which is disfluent. So attention would continue to inhibit make. So the eventual selection of a language might be some kind of summing of these contexts. And the beauty of it is that you could have different summings. I mean, so different groupings of contexts could add together in different ways all the time to constantly create new patterns, which would restrict the language and in new ways and actually be expressions of different order in the world, meaning in the world. So you can see here, I've got that you have uh, attention inhibits make, and maybe it's the next one. You get both of them activated, and the grouping there's a summing of different groupings to provide a um, a net uh, restriction on what is a fluent sequence in the language. So this is the way that I'm working with at the moment, might be a possible implementation of this symmetry restriction idea. And there's some more. Okay. Let's go back to what I had. Presentation. Just see how we're going for time here. I think I was on 15 minutes, but so I'm looking at it, and so what you're getting with this kind of structure is when I said you will have that the process of language models should be changed to be finding symmetries through the kinds of oscillations. I think this might be that and a way of implementing those symmetries to make predictions, and it will generate so it kind of generates expansions of patterns which will add to find patterns and new patterns in real time. And in practice, this is the kind of structure that I've been able to generate so far for a sequence like I think it's the cat sat. And what I'm seeing here is a kind of oscillation of activations of actually within words, within letters, to but creating patterns by having this backwards and forwards summation of energy spread and activation. So and this is a stage I've got to, but if I'm very happy to talk about how this might be implemented. There's still problems with how that might generate the structures we need. So I'm very happy to talk to people about that. And just finally, as an aside, today I was looking on X and I was interested to notice somebody talking about diffusion models, which I kind of related as an energy-based and more so finding structure late rather than trying to do it in a single learning phase. And I was just interested to see that apparently, so Elon Musk is responding to a Twitter thread today saying that apparently his AI endeavor is also working on energy-based diffusion models, which is not exactly the same as the chaotic symmetry-based idea that I'm working on, but it's in that direction, so it's good to see. So, okay, I think I've possibly over 50 minutes, but that's what I'm working on. I'm sorry I can't be there to answer questions and chat about it with you further, but anybody wants to get in touch, I'd love to talk about it. Let's brainstorm and see how we can make it a reality, because it needs to happen because we need AI like this. Thank you very much. And